Hello everyone, welcome back to another GIS lecture video. And in this lecture video I want to talk about an alternative approach that we can take to calculating, or should I say recording, location. So in the previous few videos we talked about ways that we could record latitude and longitude and what those meant. What I want to briefly introduce here is the idea of Cartesian coordinates. We will spend a lot more time talking about Cartesian coordinates in later videos, but for now I just want to introduce the concept as a juxtaposition to the idea of latitude and longitude. So let's go ahead and give ourselves a little bit of space here. Let's talk about the idea of Cartesian coordinates. So the idea here being that instead of measuring things with latitude and longitude using angles, we're measuring things with x and y using distances. From an origin. Oops. Right. So let's imagine for a second that we have our Earth like we did before. Right, with our equator and our prime meridian. Right, and we said that we can use this 0 point with the equator and the prime meridian as the measurement for east and west angulars through the center of the Earth, or north and south angular through the center of the Earth. But what if instead we took this and we smushed it flat? So instead of measuring angularly through the center of the Earth, what if instead we smushed it flat? And we took our sphere and we smushed it flat, and we had the prime meridian and the equator like that. This is called a map projection. Right, the process of going from the 3D surface to the 2D surface is called a map projection, and we will spend a lot of time talking about map projections later on. But suffice it to say, what I want you to get at now is that we have the capacity to go from this 3D representation of the globe to this 2D representation of a map. So this is 3D globe to a 2D map, right? And so what we've done is we've taken our prime meridian and our equator. So we have our equator here, becomes this axis here, and our prime meridian here becomes this axis here, right? And this intersection point here, which was our 0 latitude, 0 longitude, becomes this point here, or our origin. Right, and so what we can do is, rather than measuring angles between you, the center of the map, and the equator or the prime meridian, instead, if this is you here, let's use a slightly lighter color. If this is, if this is you here, right, you have gone some distance along the equator which we will call x, right? Because this is just like the Cartesian coordinates you learned about in high school, right? You've gone some distance along the equator x, and you've also gone some distance parallel to the prime meridian, or y. right? And so rather than designating it in a three-dimensional sense along a curved globular surface, right, we can convert to a 2D surface, and we can give you that same, I say same, we'll talk about why it's not exactly the same later, but we can designate u in terms of your x and your y relative to your distance relative to the equator and your distance relative to the prime meridian. Okay? So hopefully this makes sense, this idea of Cartesian coordinates being used as distances rather than angles, because we've converted from a 3D globe to a 2D map through the process of map projection. And we will talk at length about how we are able to convert back and forth between these two in much later videos with much more detail. But for now, as an alternative way of recording coordinates, we can also record coordinates as x's and y's relative to a map projection. So hopefully that makes sense. And if you have any questions, as always, please reach out. Thank you.